Afternoon to one and all present here. Chief guest of today's function, Dr. Vijay Kumar Saraswat, Honorable Member Niti Ayog, Guest of Honor, Dr. S. Gomathi Nayagam, former Director General, National Institute of Wind Energy, Dr. N. Anandavalli, Director, CSIR-SERC and Coordinating Director, CMC, Dr. S. Parivallal, Chief Scientist and Advisor Management, Dr. J. Rajashankar, Chief Scientist, Sri Loknath Patnaik, Administrative Officer. I request all of you to kindly adorn the dais. Dignitaries on the dais, invitees, colleagues, and friends. It is my pleasure to welcome you all to the 60th CSIR-SERC Foundation Day and the inauguration of our Diamond Jubilee celebration. We are honored to have you all here to mark this momentous occasion. Let us begin our program with the rendering of Tamil Thai Varthu. I request all of you to please rise. Thank you all. To mark the auspicious beginning of today's celebration, we will now proceed with the traditional lighting of the Kuttu Vilakku, the ceremonial lamp. For this, I invite the dignitaries on the dais. Thank you. CSIR-SERC was established as an independent national laboratory on June 10, 1965 to meet the country's need for a self-sufficient organization capable of developing advanced structural engineering skills. Each year, we celebrate our Foundation Day to honor our rich legacy and embark on new initiatives that drives us forward. Thanks to the relentless efforts and outstanding achievements of our esteemed leaders, we proudly stand today as one of the most recognized and pioneering institutions in the field of structural engineering. It's our pleasure to celebrate today's function, Foundation Day, with not one but two laudable chief guests. And with warm pleasure, we extend a floral welcome to them. And may I now request our director to do the honors. Thank you, sirs, and thank you, ma'am. We are now opening today's function with the welcome remarks by our beloved director, and may I now invite you, ma'am.
It's my honor and privilege to welcome Chief Guest of today's function, Dr. V.K. Saraswat, Honorable Member Niti Aayog. And it is my pleasure and honor to welcome Guest of Honor of today's function, Dr. S. Gomati Nayakam, former Director General, National Institute of Wind Energy and our own former colleague. Dr. Raja Shankar, Dr. S. Parivallal, Sri Loknath Patnaik, our seniors who are always our well-wishers, heads of the laboratories, scientists in charge of the Chennai unit of SICRI, CD, CSIO, NEERI and NML, present media, my dear brothers and sisters of this campus, Vanakkam and Namaskar. I extend my greetings to you on the occasion of Foundation Day of CSIR Structural Engineering Research Center. Civil engineering is a way of life addressing not only one of the basic necessities of humans, shelter, but also provide mobility, monitoring after construction, mitigating hazards, and include a circular economy. It is all about planning, teamwork, experience, and preparing for the unexpected. Structural engineering deals with the application of scientific knowledge to develop and improve infrastructures such as buildings, bridges, dams, roads, railways, and improve utilities. Therefore, role of structural engineers exists in every walk of life. Infrastructure is the backbone of any nation's economy. It is important to provide structures and utilities to be safe, while solutions need to be environmental, friendly, and efficient as well as economy. So as we know, all 5 elements of the Panchaputas, which the universe is made of, as well as the humans we are. And as I see the 5 elements of structural engineering as the sky element is the space for constructing buildings and structures, movement represented by air through bridges, railways, and ports, energy represented by fire, monitoring after construction to prevent unwanted events, and protection represented by water, mitigating natural and man-made hazards. And the 5th one, earth, encompassing all the 4 towards sustainability and circular economy. So our aim and goal to provide safe and sustainable structure is the inner layer, which can be achieved through good configuration and by ensuring strength at the first layer, while load calculation analysis and by ensuring stability at the second layer. It is important to ensure serviceability and use appropriate materials and design and detailing. This is the 3rd layer. It is essential to monitor and maintain the structures after construction so as to ensure sustainability. So these are the 5 layers of structural engineering towards achieving safe and sustainable structures. So as Dr. Bharati Priya was telling, the journey of CSIR-SERC started with a thought process of Professor G.S. Ramaswamy, our founder director. It was built upon the far-sighted vision with the aim to have self-sufficiency in structural engineering skills and was established on the 10th of June 1965 as a national laboratory under the CSIR Ministry of Science and Technology at Roorkee. It was felt that a regional cell in the southern part of our nation was essential, and it was established on this campus with other regional units of various CSIR laboratories in early 1969 and transformed into a full-fledged center. Each of the structures in this campus has a technical story behind it. The first few of the buildings, such as concrete testing laboratory, have a funicular shell roof that was developed by CSIR-SERC, the heavy testing laboratory with a brick shell roof. Heavy-duty floor of this laboratory was reinforced with the deformed grip bar, which was developed by CSIR-SERC and was commercially produced by Tata Iron and Steel Company, which has generously donated 50 tons for this work. Hemispherical braced domes patented by CSIR-SERC is shown in this slide, and it was used in the design of roof of Central Complex Auditorium of BARC. So the demonstration buildings were built in-house and the implementation was outside based on the demonstration buildings. Throughout the journey, CSIR-SERC has been contributing to solving structural engineering issues. To name a few, high-strength deform bars aiming at import substitution, pre-stressed railway sleepers towards green solution, India's first fly ash building with about 30% replacement of cement with fly ash way back in 1970s, pre-stressed hyperboloids, prefabrication in the early 70s, and in the second 2 decades towards nation building and societal development to give a few contributions, name a few contributions: aerodynamically shaped cyclone shelter adopted for Odisha super cyclone, and 23 such shelters were installed, and they save more than 40,000 lives every year. Addressing various vibration issues of turbo generators, foundation, lowering on in-service pipelines, and in the next 2 decades, we were concentrating on interdisciplinary research and development. In recent years, scientists of CSIR-SERC are focusing their research on 6 thrust areas, namely structural health monitoring, disaster mitigation, advanced materials for sustainable structures, special and multifunctional structures, offshore structures, and energy infrastructure. Recent scientific and industrial contributions or integrity assessment of Polavaram Dam through acoustic emission technique and advanced NDT techniques, testing of LCH, external auxiliary fuel drop tank, type designs of high capacity explosive storage structures, development of indigenous emergency retrieval system, power lines, indigenous know-how on engineering of floating offshore wind turbines and floating offshore platforms, solar platforms. Dissipative fuse links, textile reinforced concrete products, mathematical formulation of phase field method, 3D printable various concrete mixes including fibers, geopolymer, ultra high performance, condition assessment of RCC structures of Tapovan, Vishnughat hydropower projects, design of semi-buried hardened aircraft shelter. A compendium of projects carried out by CSIR-SERC for various sectors is being released today. Thanks and appreciation are due to Dr. Mohit Verma, Dr. Arun Sundaram, Dr. Sundar Kumar, Dr. Amar Prakash, Dr. J. Venkatesan, Dr. S. Vishnuvardhan, Dr. J. Prabhakar, Dr. Srinivas, Dr. Sabdarishi Shasmal, Dr. Parivallal, and Dr. G. S. Parani for compiling the input on various sectors, and to Sri R. D. Satish Kumar and Srimati Aishwarya for their timely effort to bring them in physical form. Our vision to become global leader in structural engineering is built upon a strong foundation and dedicated team. And our research contributions enter into practice indirectly through various codal provisions. Our scientists are members of many of the BIS committees relevant to structural engineering and in working groups towards revision of codal provisions. Towards capacity development, CSIR-SERC organizes and continues to organize a number of advanced courses and webinars on topics covering various aspects of structural engineering. And the need for a journal in India devoted exclusively to activities in the field of structural engineering with special emphasis on research and development had been felt for a long, and to meet this demand, CSIR-SERC decided to undertake the publication of a journal titled Journal of Structural Engineering, JOES in short. The first publication came in April 1973, and I'm happy to share that today we are going to launch the online submission portal. The credit goes to the team, Dr. Sabdarishi Sasmal, Dr. A. Ramchandramurthy, Dr. M.B. Anup, with the software team consisting of Srimati Chitra Shankaran, Srimati Anna Selvi, Dr. S. Vijayalakshmi, Sri Ananta Krishnan, and Srimati Surya. I am proud and of each and every member of my CSIR-SERC team. I am happy to share that 25% of the scientists, 60% of the administration staff, and 75% of the finance division staff are women. Today is a day as we cherish our achievements. We need to put ourselves on a much higher platform so that we will become a global benchmark. We need to be competitive for ourselves. My dear brothers and sisters of this campus, a person with far-sighted vision, Professor G.S. Ramasamy, has founded this institution, and former directors Dr. Ramaya, Dr. Raman, Dr. Apparao, Dr. Lakshmanan, Dr. Nagesha Iyer, and Professor Santosh Kapuria, and staff members have made a strong foundation upon which we stand today, and it is our duty to pay our gratitude to them by keeping the campus vibrant with our outstanding scientific contributions. Thanks are due to Dr. R. Narayanan, Dr. A.P. Mandal, Sri Shyam Shetty, Dr. K. Ramanjanelu, and Dr. Rajashankar. We owe to our research council members for their broad R&D policy, guidelines, and directions time to time. We acknowledge our clients and industry partners. And I'm confident with my smart people, simple and systematic, manageable and mindful, adaptive and active, realistic and resourceful, trendy and time-conscious people, we will attain our pinnacle. This year being the 60th year for our organization, we are planning for a year-long celebration with various events. To commemorate, a logo has been designed and will be released during this function. As part of the Diamond Jubilee celebration, a conference on monitoring, assessment, and predictive maintenance of critical infrastructure, IMAP 2025, is being organized during January 22 to 24, 2025. The release of the conference flyer is also planned during this function. We are also commencing Dr. T.V.S.R. Apparao internship for undergraduate students today, and around 60 students are availing this internship this year. First lecture of the Diamond Jubilee lecture series will be delivered during this function by our former colleague, Dr. S. Gomathi Nayakam. I once again welcome you all to the Foundation Day celebration and inauguration of the Diamond Jubilee celebration. And I once again welcome and thank the chief guest who, amidst its busy schedule, accepted our invitation and graced this occasion. Thank you, sir. And our guest of honor for accepting our invitation to deliver the first Diamond Jubilee celebrations lecture. Thank you, sir. And I would like to conclude with a Thirukural. Porul Karivi Kalam Vine Idanoda Aindum Irul Dira Enni Sayal, which means do an act after a due consideration of the 5 aspects: resources, instruments, time, action, and context. Thank you all.
Thank you so much, ma'am, for your warm welcome and taking us through the journey of CSIR-SERC. Next, I would like to invite Dr. S. Parivallal, Chief Scientist, to introduce our guest of honor, Dr. S. Gomathi Nayagam, sir.
The dignitaries on the dais and off the dais, good afternoon to everyone. It is my pleasant duty to introduce our guest of honor, Dr. S. Gomathi Nayagam. Dr. S. Gomathi Nayagam is not new to our campus. As the occasion demands, I am presenting a brief biodata of his. Dr. S. Gomathi Nayagam, former Director General of National Institute of Wind Energy, has had a distinguished career in the field of renewable energy, specifically in wind energy. His contributions span across various capacities, primarily focused on the research, development, and promotion of wind energy in India. He obtained his BE in REC Trichy, MS and PhD in IIT Madras, and he did his postgraduate diploma in public procurement from AIMA, World Bank, New Delhi. He started his career at CSIR Structural Engineering Research Center, Chennai, and served for about 25 years, from 1983 to 2009. His research area include wind, wave, shock and impact, earthquake, and tsunami effects on structures. He has undertaken several interdisciplinary research activities and full-scale tests for space, Navy, Air Force, energy, railways, and telecommunication. He was responsible for the creation of the Field Experimental Laboratory in the area of wind engineering and undertaken several challenging industrial projects in structural engineering. Then he moved to National Institute of Wind Energy, NIVI, as a Director General and led the Institute in Wind Energy Technologies. He played a pivotal role in development of Wind and Solar Resource National Data Network and the release of Indian Atlas. He established real-time wind power forecasting and scheduling. During his tenure, he generated revenue from the wind energy industry to the tune of around 105 crores and achieved self-sustain in terms of salary payments for around 165 employees. Presently, he is an independent consultant and procurement management advisor on wind and solar energy development. He is undertaking industrial consultancy and multidisciplinary engineering advisory services, including structural analysis, design, testing, and field measurement. Actively involved in engineering and institutional capacity building, dynamic project management, international project management, IPMA certification, corporate executive training, renewable energy and sustainable global energy transition testing. He has participated in various forums as chairman and member of high-level institutional committees for selection, project management, and monitoring. As an invited faculty and speaker by industrial body and academic institutions, he has presented at 300 national and international conferences and symposia. He has published around 75 research papers in international and national journals and 25 articles in popular magazines on wind and renewable energy. His awards and recognitions include DAD Fellowship, UNDP, and AUSAID Fellowships. His successful international collaborations resulted in business model solutions for the wind energy. He has visited vastly at different countries, USA, Germany, and most of the European countries and the CSIR countries, name a few. With this, I request him to deliver his lecture. Thank you.
Good morning. It gives me great pleasure to be on this dais, CRC, where I worked for 25 years. And that too, it's a great honor to be presenting a small lecture in front of Padma Shri Padma Vibhushan, Dr. Saraswat, whom I have been watching from distance. He's a dynamic leader, eminent scientist, and very active and very dynamically thinking about innovative concepts for nation building. And it gives me really great pleasure to give this small overview of emerging trends in energy engineering structures. I also thank my colleagues on the dais, off the dais, and my fellow ladies and gentlemen. Thank you for the opportunity. Let me start my topic, which is, again, I used ChatGPT AI for the first time to create these quick slides. And with that acknowledgement at the bottom of the slideshow, let me go through the slides. So we have, SERC is not new to power plant structures, be it chimneys, cooling towers. We have been doing wind analysis, design reviews, and consultancies, and so many other things. And turbo generator foundations is a regular consultancy for us. And yeah, this one. This is to slide move. Okay. Yeah. So now we are in the renewable regime. India has set a target of 500 gigawatts of renewables by 2030, which is a very huge target. In 2014, it was just a mere 20 gigawatts. And 2014, they announced 175 gigawatts, and by 2022. But now, after COP27, Honorable Prime Minister has announced 400 gigawatts and 500 gigawatts now by 2030. That's the target of renewables. And we are getting fast track towards that project. And some of the structures which you might come across in future would be offshore towers, floating and fixed, and very tall wind turbine towers of 120, 150 meters tall, and very large wind turbine blades, right now up to 60 meters in India. In the world, it is about 130 meters. And India's largest floating solar project is in Kayangulam, Kerala, which is one of the largest, 101.6 megawatt project. So what are the challenges in traditional energy engineering? Why we call it energy engineering? You think of any energy, they require structures. It could be pressure vessels, it could be boilers, it could be support structures, it could be foundations, towers, and blades for the case of wind turbines, and so on. And the traditional energy structures had limited sustainability because it cannot go further because the resources are limited, resource dependent, fossil fuels are going to be depleted soon, and high environmental impact. It has a very high pollution in the ground. So we are now moving towards renewable energy sources. Cautiously, India has declared net zero by 2070 because as a developing country, we cannot use base power other than coal some more time, for some more years. So structural design challenges are going to be there in renewable system when we are moving towards net zero by 2070. Economic viability and rising demand for renewables now, and that cost is increasing. That means we have to cut costs somewhere, that for which it requires a lot of innovations. And technological advances for offshore and onshore, and also what you see here is a solar thermal tower. The solar heat is reflected onto a tower wherein you can get superheated steam, and then that can ride a boiler generator and you can generate power. So there are umpteen ways of using renewable sources of power and generate, but every source of power, when you want to convert to electricity or any other means of energy, we need structures and systems, and which require enormous input from structural engineers. Innovative materials and technologies in structural design for future trends, and some of them I can highlight. Advanced composite materials are being used now, and smart building systems are going to be there because green buildings require embedded sensors into the building materials, and you have to manage the energy, net positive energy of the building has to be there. And 3D printing, already SCRC has demonstrated 3D printing innovation in a small scale, and it will be going to be there in prototype soon. Then we have energy efficient strategies. When you want the green buildings, for energy efficiency you need support structures, sensor supports. Sensors should function and meet all the functional requirements, and passive design solutions with low energy consumption. Passive design solutions are required, for which structural forms and the design of that is important. Then we have to have IoT, Internet of Things, enabled devices, sensors being embedded, and it will improve operational performance, easier maintenance, and energy engineering systems. And we need of all the things, synergy from CSIR-SERC with National List of Wind Energy, National List of Solar Energy, National List of Bioenergy of Ministry of New and Renewable Energy, along with the International Solar Alliance, which is one of the topmost apex bodies in the world, headquartered in India. And we need to ensure in future the P2P, person-to-person energy sharing within connected community, because energy is going to be digitally managed. No more distribution systems are analog. It will be controlled by digital networks. Offshore wind power developments are very fast. Most of the countries which are dominant in offshore wind energy exploitation, they have taken about a decade or so to take their first offshore wind farm. We also started in 2010 with the offshore wind energy discussions with Scotland, And now we are in a position to leave out a tender for Tamil Nadu, 4 gigawatt in Tamil Nadu, leasing 1 square kilometer of seabed for the highest bidder. 1 square kilometer of the seabed leasing for seabed survey, marine biodiversity surveys, and so many other things which are involved in offshore wind power development. All the surveys have to be completed, and seabed exploration and seabed, the suitable foundations have to be designed. And we can think of in one machine, 15 megawatts with 236 meter diameter blade. That is such a long blade. In one machine, we will get 15 megawatt. So that's the order of scale of development nowadays. And this is a large wind turbine blade under test in Denmark, Blast company. And the testing is happening in the ambient outside environment. And the vibrator is to simulate the fatigue stresses on the blade to endure the fatigue life of the blade. And another important thing is, when you design the blade, it has to be designed for logistic transportation along the roads and to be taken through the barge and to be installed in a site in offshore industry. So there are several things structural engineer have to think of while even at design stage. Okay, if you just look at the case study of floating solar farms, it utilizes unused water surfaces, enhances renewable energy capacity, energy positive buildings, ensures surplus energy, offers potential for sustainable urban development, and digital twins and blockchain for supply chain management. This is going to be there in offshore wind farms, because offshore wind farms cannot be accessed as and when required to rectify defects. They have to be very highly reliable, and the access is limited because it is seasonal. You have to wait for the sea to be calm before you access the defect addressing, or you have to go through a helipad and so on. So digital twins is going to solve these overall problems. And future outlook, emphasis on energy decentralization through microgrids, and we'll come to that in the next few slides. Integration of AI and machine learning in predictive energy management, smart grids, and so on. Innovations in wind turbine blade structural designs definitely largely depends on the structural engineers building in efficiency in the blade, aerodynamic design, as well as the structural design. And performance, high performance, then you get more energy captured. The environmental impact will be less because the noise will be less, and the death of birds or bats will be less. And when other challenges in traditional designs are fatigue and manufacturing complexities, they're all overcoming now with innovations in material. Conventional materials are used for blade construction, may have limitation in strength, weight, and nowadays we are using carbon fiber material advancements, blade materials, smart polymers, and morphing of blade profiles like the sea animals, large sea animals, and aerodynamic bird wings and so on, and design enhancements, integration of technologies, both digital manipulation of stresses in the blades. You can embed fiber optic sensors inside the blade during casting and monitor it 24/7. And these are all the gains you'll get such innovative designs are, if you use advanced composites, the performance increase is about 12%. Morphing blades can increase performance by 18%. Smart polymers can increase by 15%. So structural engineers have a large role to play in the future. Not only in the blade design and efficiency building, even after the end of life use of the blade. The Denmark has showcased how you can use the end of life use of the blades to bus shelters, and how to use them in integration, collaboration, and so on. And this is going to be there. We will be coming through these things future. That also requires structural qualification, because it involves public being sheltered in bus shelters and so on. Then challenges in traditional support systems. Onshore, we have seen the height will be limited, the length of the blade will be limited to transfer through rural roads, and offshore that limit will be obviated, because you can create in the factory coastal area and unload any size of the blade, any size of the tower, any weight of the nozzle onto the barge and go to the site and install and commission. So all these sustainability and environmental impact must be addressed. And also in India, there is only one company right now supplying, one or two companies supplying tall reinforced concrete towers for wind turbine supports. But there will be 30% cost saving than steel, and you can build and reuse the concrete towers built in forests, because you can take only the materials without cutting trees, and then erect an in-situ concrete tower or a precast concrete tower, and then the same tower can be used to, when you want to upgrade the machine, you can use the same tower with a upgrade, because its life is durable, it's long lasting. So 30% cost saving there. Beyond 70 meters design, it could be 30% saving. Then enhancements in offshore wind turbine supports, and we need to have factories on the coast so that you can load out like 3,400 tons topside, which is a substation, will be supported by 1,400 tons of jacket. And it should be corrosion resistant, and floating platforms also are going to be used. Adaptive foundation systems like friction bucket, suction bucket systems, which will adapt to the seabed shape automatically. All those things are going to be there, which are going to be the challenge. Onshore, offshore support, design flexibility, you have limited by land availability, adaptable for deep water in the case of offshore support. Construction costs, lower initial cost in the land, but higher initial cost, but the potential yield is much more higher. 10 to 20% more energy can be captured in the offshore, because it is a smooth surface. It's not a turbulent wind during the energy production. Not during cyclones, it is not possible. Beyond 25 meters per second wind, most of the wind turbines will be stopped to resist the extreme wind. And maintenance accessibility is easier in land, but it will be highly challenging in offshore. That means you have to build in a lot more reliability through digital twins and IoT and ICT and so on. Then hybrid support systems, optimize energy capture. You can tune the floating platform to any kind of sea state, and that kind of systems are going to be there in future. And there are many features. I will leave the slides with you to read because of the short time limitation. I'm rushing through the slides. Right, structural integrity. When it comes to solar, which has taken over the wind now, even though it started late, it has taken over the wind in a big way. The solar integrity, structural integrity, and weight and load distribution, you need what is known as a duck row, kind of a solar, floating solars are coming up now. Adaptability and modularity must be ensured in solar. So solar has three fields. One is photovoltaics on ground, then float voltaics, floating solar systems, and then third one is agri-voltaics. I'll come to that one by one. Innovative design solutions for float voltaics. So these are some of the innovative things coming up in solar. That is integrated smart trackers. As the sun goes from east to west, it will track smartly, and that will increase 20% more energy production. And this is different bifacial modules and different curved element floating elements. The second one, what you have, that's also in another. These are all prototype already implemented, not imagination. Then materials and construction techniques, high strength alloys are being used. Already we started with rolled steel initially when the solar farms. Now it's cold form steel. Now it is high strength alloy steels. And prefabrication, modular assembly, recyclability and circular economy must be ensured at design stage by structural engineers. Okay? And solar is mostly a EPC contract. It's a plug and play system. And structural engineers have a lot of role to play there. Right? Then environmental impact and cost analysis in solar. We have sustainability metrics, life cycle cost analysis. We should be proud that world's largest gigawatt solar park is India. India's pride is already given in the National Geographic. Can you try to play the video for 1 minute? If it is working. It's partly in Hindi.
शुरुआत पार्क के साइज से करते हैं। ये पार्क इतना बड़ा है कि यहाँ मुंबई के वानखेड़े स्टेडियम जैसे 1000 से भी ज्यादा स्टेडियम बनाए जा सकते हैं। अब जरा इन सोलर पैनल्स को देखिए। सूरज की किरणों से पावर जनरेट करने की जिम्मेदारी इन्हीं की है।
India is blessed with sunshine and 330 days to 350 days in a year, bright sunshine, which is about 5 hours per day, bright sunshine. So that helps in solar power generation.
चलिए मैं आपको समझाता हूँ कि ये पार्क कैसे काम करता है। जब सूरज की किरणें मॉड्यूल्स के सेल से टकराती हैं, तो इलेक्ट्रॉन्स काम करना शुरू करते हैं। इससे डायरेक्ट करंट बनता है और सोलर पैनल्स की वायरिंग में कैद हो जाता है। फिर इन्वर्टर्स उसे ऑल्टरनेटिंग करंट में बदल देते हैं और क्लीन रिन्यूएबल एनर्जी बना देते हैं।
In quantifying the wind loads in these kind of
सूरज
large
ढलने को
solar
है
panels,
और
we
पैनल्स
are yet
पर
to
धूल
devise
जमने लगी
innovative
है।
methods. SCRC is working on it because the
Dust
loads
is a major
affected by the
challenge
end
for
solar panels
any
not
solar
the
power
same as the
generation.
one
Every
which is
day,
attracted
because of the wind,
by the
so the
middle
sand
of
gets
the solar
deposited
farms. You can,
on the solar panel.
In 100 megawatt solar
पैनल्स की सफाई के लिए इस्तेमाल किए जाते हैं स्टेट ऑफ द आर्ट पावर एफिशिएंट रोबोटिक क्लीनर्स।
by proper design.
ये इकोपिया रोबोट्स व्हील्स पर
So this is, they use a robotic cleaner, right? Yeah, go to the next slide. No problem. Okay. This is another area which I said agrivoltaics, wherein we have to allow the cattle to clean up the grass, because we have to keep cutting the grasses under the solar panels. So we have to allow the cattle to go through the grass. That means it requires very proper design of the height of the module mounting structure. These things are yet to come up in India. If this happens, we can have even agricultural lands being used partly for these kind of solar farms, for microgrids and so on. Then the last one I would like to touch upon is green hydrogen innovations and renewable energy dependency. Green hydrogen is produced with renewable energy as the input. In that case only we can have green hydrogen. And there are other ways of producing renewable energy. Hydrogen production heavily relies on renewable energy sources, and scaling production and cost-effective electrolysis must be done. And of course, hydrogen applications are plenty. Pharmaceutical, transportation, synthetic fuels, upgrading biofuel, ammonia fertilizers, metal production, chemical industries and so on, ammonia production, fertilizer production, everything. So in addition, it can also be used as fuel in fuel cell cars. Novel engineering solutions use novel electrolysis techniques which will use solid oxide electrolysis cells and proton exchange membrane electrolyzers, smart grid integration. This is one such system formatted by Siemens Gamesa, integrated renewable energy system for hydrogen production. Storage technologies also, we can use natural caverns, salt caverns, and or you can build underground tanks which will resist the pressure of the compressed hydrogen storage, liquefied compressed green hydrogen storage, and that can be used as and when needed in the grid to manage the grid. And transportation innovations, hydrogen can be transported continentally by storing in liquid form, just like petrol, because I just want to remember, hydrogen is not a fuel, it is an energy carrier. When you convert in terms of renewable energy, it is only a carrier. It can be stored and transported everywhere. Okay, when it comes to these kind of systems, structural engineering systems, we need head of service operations, head of learning and development for industry, head of supply chain, then head of environment, health and safety, quality, SCADA system, and health of technology. all that we need energy engineering projects, we need competence of the people. That's what SERC is already doing periodically through advanced training in very highly multidisciplinary areas of structural engineering. And we need this because ICT, IoT, in Industrial Internet of Things, digital twins, blockchain, AI, machine learning, virtual reality, augmented virtual reality, you can name the new technologies that are going to come up with all this. Structural engineering is merged with every discipline, and it has a multidisciplinary approach. We need to develop the people. Finally, I acknowledge the resources, including the ChatGPT, which helped me to form the first profile. And I thank CSIR-SERC to giving me this golden opportunity to address you all, to interact with you. Thank you.
Thank you so much, sir. It was a fitting first lecture for our Diamond Jubilee lecture series. Thank you very much for that. Every year, our Foundation Day is celebrated with a memorial lecture in the memory of one of our visionaries, Professor G.S. Ramaswamy, the founder-director of CSIR-SERC. This year, we are honored to have Dr. Vijaykumar Saraswat to deliver this lecture. Before we move on to the lecture, I now invite Dr. J. Rajashankar to formally introduce him to the audience.
Very good morning to the dignitaries on the dais and my own colleagues of this campus, past, present, and future of the CRC. Media, ladies and gentlemen, it's my great pleasure. I think it has been announced that it's a very special day of this lab. 60 years back, this lab was inaugurated on this, notionally on this day. And after 60 years, we are now assembled again to celebrate this momentous day. And again, we have the illustrious gem of the country, the think tank, member of the think tank of this country, Dr. V.K. Saraswat, among us to deliver the Professor G.S. Ramaswamy lecture or memorial lecture. And it's my personal great pleasure to introduce Dr. Saraswat to the audience. I know Dr. Saraswat doesn't need any introduction to august audience like you, but it's my present duty and as the occasion demands. Now coming to the biodata, Dr. Vijaykumar Saraswat is a member of the Niti Aayog, Government of India, is a think tank, and he's a highly esteemed scientist. Initially he's a scientist, that's basically he wants to qualify himself as a scientist. So we are all feeling proud of our own profession. And he's a member of Niti Aayog, renowned for his extensive experience in defense research encompassing both fundamental and applied sciences. Having served as the Secretary of Defense Research and Development Organization, DRDO, he has made remarkable contributions to the indigenous development of missiles like Prithvi, Dhanush, Prahar, and Agni 5, as well as two-tiered ballistic missile defense system. I think defense as well as the missiles. And Dr. Saraswat played a pivotal role in establishing infrastructure to support the nuclear doctrine, developing cybersecurity technologies, and enhancing nationals' defense capabilities against ballistic missile threats. Furthermore, he has been actively involved in the development of alternative energy systems, it's notable, and such as clean coal technologies, concentrated solar power systems, and bioenergy, hydrogen-based economies, all that our guest of honor spoke about. And he has been pursuing major initiatives in the sustainable and resilient transportation system, namely e-vehicles, FCV, hybrid vehicles, and hydrogen-powered long-haul transport systems, very specifically. And Dr. Saraswat has also made significant contributions to the advancement of technology, including the development of silicon photonics, configuration of M processor for ICT applications, and the roadmap for the Indian Railway Research Institute. And finally, as a member of Niti Aayog, Dr. Saraswat has initiated the methanol economy program aiming to utilize methanol for transportation, energy generation, and chemical production. Additionally, he has chaired committees on technical textiles, body armor, contributing to the futuristic growth of these sectors in India. And Dr. Saraswat's outstanding achievements have been recognized through numerous awards. He has not listed his awards, but including Padma Shri and Padma Bhushan, and not less, and as well as honorary degrees, honorary doctorates from not less than 25 major universities of the country and abroad. It's a great honor for all of us. It's a pleasure for all of us to have you, sir, as our chief guest and hear you just now. And floor is yours.
Vanakkam. Very good afternoon. Let me greet some of the eminent on this occasion about structural engineering advances. While Dr. Gomati Nagam talked to you all about the energy-related structures and how what is to be done because of his background with SCRC and also the kind of work which he has been doing in the Energy Institute, Wind Energy Institute. I've also been part of the energy segment for the last about 10 years, and many of the things what he talked, we have been practicing, trying to give people the ideas as to how they should go. But today we are talking about structural engineering advances, so let me start with that. So if we look at structural engineering, it drives infrastructure because it is related to the society. You saw all the implications, all the applications of structural engineering. This is part of the society. We have, Madam Anand really talked about infrastructure is an indication of growth, economic growth. If you look at the parameters, we directly link today in Niti Aayog, the investment in infrastructure are really one good indicator. So it drives infrastructure development, underpins the creation of critical infrastructure like bridges, roads, and so on. And it is, as I mentioned to you, a catalyst for economic growth, because when you do economic growth, you generate jobs and construction activity, new businesses are generated. We are all talking of safety because ensures public safety, because all the buildings, all the towers, everything has to be risk-free, so we have to save against disasters. And the other point which Dr. Gomati Nagar mentioned was the E law of sustainability. Today we are all talking of sustainable development, and hence modern structural engineering emphasizes sustainable design principles, and obviously it enhances the quality of life. But the approach what we are talking with respect to evolves with the regions of economic growth. We have once upon a time the reactive approach where we were struggling to keep pace with the demand, where minimum urban infrastructure to meet the basic human needs used to be our requirement. So we were looking at basic housing, we were looking at water, we were looking at market and so on. Then we came from basic infrastructure to ensure more basic needs like hospitals, schools, roads, bus buildings and so on, and sewage. Then came the advanced infrastructure geared more towards mass transportation, metros, air, railways, and natural disaster risk-free systems, educational and research institutions, so on. And now we are all going into the proactive mode where we are looking at eco living, we are looking at culture, we are looking at leisure, we are looking at environment in a big way, which is the quality of life. So availability of first-class infrastructure is a must to achieve broad and inclusive growth on a sustainable basis. Sustained infrastructure growth can comprehend the vision of becoming a 40 trillion economy by about 2047. So, what is the kind of investment that is taking place today if you look at in the infrastructure segment, which is essential for the economic growth? You see, the overall investment is about $69.4 trillion for, which is between 2017 to 2035. 54% of the world's infrastructure investment will be in Asia, and the bulk of this will be shared by the world's two fastest growing economies, namely China and India. India will be about 8%, whereas China will be about 34%. And emerging nearly 2/3 of the global infrastructure investment in the period to 2035 is going on in the emerging economies. The two bar charts what you are seeing in the ground indicates what is the percentage happening in the Asia, Europe, India, US and so on. I just want to give you an evolution. Many of you might not have, although you are practicing structural engineers, but you might not have actually gone into the historical evolution of this particular science. In 2650 BC, we had pyramids. I don't think anybody knew what kind of structural engineering we were talking at that time. Then came areas of center of gravity, that is the 3rd BC, and where you started using lever for the first time. First time you realized what lever can do. Then came in 1638 the material strength, motion and objects. 1676 was the first time Hooke's law was invented. 1687 you had laws of motion coming from Newton, and 1750 you had beam equation theory of virtual work. 1797 you had cast iron, and cement came in 1824. Elastic modulus was discovered in 1826. Then cast steel 1858, reinforced concrete in 1867, and now we are all talking of 1930, where we had movement distribution method and calculations done by the hand. Pre-stressed concrete in 1928, and all of us know that Eiffel Tower was in 1889, and the first skyscraper was in 1885. So 1956 we started using cast steel, and I don't know how many of you were there in the 1956 when the finite element methods came. 1956 was the year when I joined as a 6th grader or 5th grader in my school. Of course I didn't know what was IFEM at that time. So then 1965, that was the time when I was doing my engineering. The Nastran came, and 1969, it was my, I think, final year of engineering when we started hearing about Nastran at that time, not using it. But today we have a variety of things which we started using as a practicing engineers in DRDO, 1982 AutoCAD, then Midas Civil 2001, and today what we have, the Building Information Modeling, BIM, which is the latest what is happening today. So with the rise of ancient civilization, all this has happened. FEM, AutoCAD, Nastran, BIM, they are all the things which are recent advances in structural engineering methods and technologies, if you look at, for example, if the construction is taken as one of the major areas, we have accelerated and disturbance-free construction methods which are evolved now. We have additive manufacturing. Dr. Gomti Naik did mention about 3D printing, which is a form of additive manufacturing. Automation and robotics, BIM and augmented reality, and lean construction. All of us are looking at lean construction today, not a very heavy construction. And digital collaboration tools, he also mentioned about it. The structure is today hybrid structures, high degree of prefabrication which is taking place. New structural systems are evolving now. New connection systems are also happening. Floating structures emerging, which was again highlighted by Dr. Gomati Naik, and lightweight structures, which is happening today. Materials are playing a major role. The materials are evolving over years, and now the era of sustainable materials are there. So high performance materials. He did mention about alloys, super alloys, cast alloys, and things like that. Materials with specific properties which are needed for specific jobs. Recycling of materials, smart materials. I was very happy to see that you were using fly ash as far back in 1970s for making building. Today we are discussing how the fly ash can be made for making houses and so on. So there have been, you were the early starter at that point in time, I must say. The design methods have also modified considerably. We have today integrated interdisciplinary software. I was given to understand that you guys were not allowed to use the available commercial design software packages, and you developed of your own. I hope that you have done your IP and you have taken the kind of patents which are essential. And if you have done that, India would be boasting today of its own FEM package, our own Nastan kind of a thing and so on. So I think that was a good thing, but sometimes we should have a combination of both. I believe in that. So site-based design, design optimization, sustainability and performance criteria, all these are design methods. Structural analysis and monitoring, all of us were very happy once upon a time when we were studying only linear. Non-linear systems are emerging today. Multi-scale tests are emerging. Structural health monitoring, which was identified again for various applications. Vibration-based damage detection, fiber optic sensors, smart sensing technology, and unmanned aerial vehicles for doing the monitoring. Similarly, evaluation and decision tools also are going into the digital domain, where data collection from construction sites and use phases are being monitored today. Analysis using machine learning, life cycle sustainability assessment, and collaborative project organization. These are all major things which are happening today. The top structural engineering trend today is what we call as the building information modeling. I don't know how many of you have started using this as a part of your exercise, but project management is revolutionizing the construction industry by serving as a platform to virtually produce designs and manage projects through their life cycle. And collaboration, BIM helps generate the multiple layers of metadata and integrate them into collaborative workflow. Then the modern approach, it assists in designing and management of projects in a collaborative nature. I think design, build and operate, this is the kind of mantra which is needed, which involves right from the architecture to furnishing to lighting, everything that is required in any building or any structure that has to be taken care of. So let us just talk about what is a structural health monitoring system. In aerospace, I come from aerospace area, so we used to do the structural health monitoring of the aerostructures. And we developed our own specific methods of doing that. And when I was preparing this talk, I found there are lots of similarities what is being done here. You have the structural health monitoring strategy, which could be a global monitoring strategy or it could be a local monitoring strategy, which depends upon what are the physical parameters you are wanting to measure and what are the sensors associated for making the measurements. For example, the acoustic emissions, you use piezometric sensors. Deformation and displacement, you use deformation displacement sensors. For frequency, mode shape and dynamic stability, you use acceleration measurement or deflection monitoring. For physical integrity, you use photogrammetry and delamination spalling, like that, corrosion, electrochemical methods and so on. So these are the systems which are to be integrated and they become part of your SHM process. So
application today in all this is going to be mainly through the artificial intelligence. AI can enhance structural health monitoring by two methods. Number one, image-based SHM, like I mentioned to you, and the vibration signal-based SHM. If you take inputs from somewhere, whichever structure you are taking, then you put through a machine learning method where you have done the supervised learning or the unsupervised learning, or you have done the reinforced learning, and then you get the output that would be sent for that. And the mechanism, like for example here what we have shown, there's a building which has been affected by earthquake. You take a image of that portion, and that image you do extraction of the features. Now you have a data set coming from the database, use the ML methods, integrate with that, and come up with the predictive method, and that will give you the seismic peak drift ratio, what will be important for that. So all these challenges, streamlining the processes, there are new ways to tackle. Generative design revolution, AI-driven algorithms can actively generate multiple design options. It accelerates the design process by producing innovative solutions. AI-enhanced simulation and analysis certainly leads to smarter, quicker, and more accurate outcomes, and collaborative tools. It can help all stakeholders brainstorm ideas, offer design suggestions, and predict potential challenges. Now, there are top structural engineering trends which are there. Dr. Gomati Nayagam did mention about IoT. It changes the way buildings are designed, constructed, and managed today. Basically, if you look at this kind of a structure, what I have shown, IoT changes the way buildings are designed, constructed, and managed. Is one of the biggest trends in structural engineering. It helps in smart manufacturing by integrating manufacturing equipment with the sensors to gather real-time data or quality and performance. And SHM certainly helps you in periodic monitoring with the updated information and prevent the deterioration of the structural health. Now you can use the kind of sensors which are indicated here, like strain gauge, strand meter, crack meter, displacement sensors, and so on. And from all these sensors you get data as shown here. You get the local data, you can transmit it to the wireless, or you can transmit to the wire. If it is wireless, and then you get into what is called the bandwidth problem. And finally it goes to what is called the data management system, where you have a central data server, which is having a data processing unit and a data storage system, and finally to the client server where the user is sitting to make use of the data. This is the kind of SHM configuration which will be useful for all structures. Now, what are the advanced technologies which are coming in today? And digital twin technology and structural health monitoring. Digital twin technology coupled with advanced sensors and predictive analysis, it is revolutionizing the way we monitor and manage the performance of structures. By creating virtual replicas of physical assets, we can simulate real-time behavior, diagnose structural issues, and optimize maintenance strategies. Unmanned aerial vehicle drones, and today they can give the advantage of this technology in the most practical aspects, like pre-planning, detailed survey, and mapping of job site. Particularly if you are going to do the offshore kind of a thing, what Dr. Gomati Nayagam was talking about, I think we need all the drone technologies there, and we will be using them extensively. Post-build checks, sales and marketing, 3D scanning of the construction site, and then use the photogrammetry techniques, and drone model can be converted to BIM model and therefore to an FEM model and analyzed after adding corresponding loading data. This is the way we will be in a position to use all these technologies. Now, another one is the 3D printing, which is also known as additive manufacturing. It allows fabrication of complex structures, layer by layer, offering unprecedented design freedom. It can be done in concrete and steel structures, although concrete and steel is still coming up, but other materials it has already come up in a big way. Layer by layer process can give complex geometries, intricate patterns. It gives you design freedom, it reduces the waste of material, and also it can locally sourced material can be used, which reduces transportation related carbon emissions, what we are talking of. Another material which is commonly now being used in the structural thing is the composites. You all know composites are a combination of two or more physically distinct phases that give properties that are different from its constituents. So when you need high strength to weight ratio, you do it high durability, you need damping properties, you need design flexibility, chemical resistance, corrosion resistance, high impact strength. All of them you can get through the composites. And then multifunctional structures where you can get acoustic attenuation structures, acoustically transparent structures, embedded systems with sensors, heaters, heating elements, and integral mechanical assemblies like actuation systems can be put inside that. Functional surfaces which can have, for example, the wind turbines, what we were talking about, the blades we were talking of. We were talking about low drag, laminar flow, hydro ice phobic, corrosion resistance, all these things are feasible with these functional structures. And basically, they are all part of the today's smart city systems which are coming using smart materials and so on. What are the new and sustainable materials which are emerging today? For example, aerogel is a super insulating material made from silica, lightweight and used to insulate winds, walls, roofs and floors. Bioplastics, renewable sources, sustainable to a traditional plastic used to make building materials. Cross-laminated timber made by gluing together layers of wood. By the way, I want to tell you the great amount of change which is taking place in the structures is the use of bamboo wood. In fact, recently in Bangalore, we have constructed a full auditorium made out of bamboo wood. No steel at all. And all the joinery, refinery, everything is done by the carpenters using the bamboo wood, designed for housing almost 300 people inside, and except for the plinth which is made out of the concrete and things like that. Nothing is there in that. So I think what we are going to use is this new technologies which are coming up in terms of wood. Graphene used to develop graphene reinforced concrete, microbial concrete, where concrete with bacteria produces calcium carbonate, which helps with strength in the concrete. Recycled materials, we talked of fly ash. Self-healing, now we are also talking of steel slag, which is being used today for roads. Your own CSIR lab is doing that particular wonderful job. Self-healing concrete, which again thing, and sustainable wood. These are some of the materials which are making the difference in the years to come. Other methodologies in the structural areas are visual programming and parametric modeling, which involves creating algorithms and design logic through graphical interfaces, making it more accessible for engineers to manipulate parameters and generate complex parametric models. The ability to see the impact of changes in the real time, which enhances the iterative design process. And this reduces errors, accelerates the transition from design to construction. Similarly, next one is coming is the prefabrication and on-site fabrication. In the case of metro construction, you must have noticed the kind of prefabrication which has been used is something happening today. And what is the kind of advantage which is there, which reduces waste, increases the efficiency, reduces construction time, and we can do better project management. Global prefabrication market is surpassed US $147 billion in 2022 with a CAGR of almost 6.5%. An increase in structural demand is coming up today in this sector. Another one is the design aspects, where we are now looking at performance-based design, which is the approach of starting from the end to the starting point and then demonstrating using analysis, modeling, and simulation to demonstrate that a structure will meet a specific performance level. PBD focuses on achieving a specific performance objective for structures considering factors such as safety, functionality, and resilience. It enables us to design to meet project-specific goals, adapt evolving challenges, and we can also look at seismic loads and wind loads through this process. Another one is the performance engineering design, where we are looking at life cycle assessment, durability maintenance requirements, and so on, which is part of our design process. The projected contribution from embodied and operational carbon within the building sector. When we generally nowadays project what is the contribution of various sectors to the carbon budget as far as the country, globe is concerned, the buildings come at the fourth point. Building. First is the power, second is the, I think, transport, third one is the industry, and fourth one is, I think, the building. If you take in that order, we are also contributing significantly as far as the carbon budget is concerned. 2021, we were 25% and 75% operational. It is expected that by 2050, with business as usual, it will be 49% and 51% of building sector carbon. That means we have to do something, otherwise we will be one of the contributors to the global warming. So there is a need for sustainable designs. Biomorphic architecture inspired by natural forms and processes is required. By mimicking the efficiency and adaptability of the natural systems, we can optimize resource utilization, improve energy efficiency, mitigate the environmental impact of the construction projects. Similarly, adaptive and responsive structures dynamically adjust their form and perform to respond to changing environmental conditions. And utilize smart materials, sensors, and actuators. Adaptive structures can autonomously adapt their shape, stiffness, and other properties to optimize energy efficiency, occupancy comfort, and structural integrity. So these are all in the form of shifting the shape-shifting the roofs, respond to the wind loads. They are called interactive architectures. So you people, as a structural engineer, have diverse responsibilities. You are supposed to be doing analysis, which takes into account gravity, wind, earthquake, everything. You are getting into design in a big way, which enhances the structural performance, and now the new technology like BIM. You are also responsible for quality control to ensure the structural integrity issues. You are also doing what is called the best material selection for cost, strength, durability, and environmental impact. You are also responsible for compliance and regulations. There are huge compliance requirements. Building construction codes are there, road construction codes are there, structural construction codes are there. So your knowledge and your compliance requirement to regulations is very, very important. And finally, what Dr. Goumati Nayagam talked in detail is the project management. Because if you want any infrastructure project to be cost effective and also efficient, I think the project management is the key word. We need to really look at that seriously, and we should become a good coordinator, because these are various segments in which you will be doing the coordination. So what are the challenges in structural engineering building the future? First is sustainability and environmental concerns for reducing the carbon footprint. Second is, we have aging infrastructure. We have seen what came out in 1965 or what came out in maybe even earlier. Those buildings, those structures, those bridges, those roads, those towers all needs how do we grapple with this idea of looking after this aging infrastructure. Then we have another requirement of resilience to the natural disasters. And the frequency of these natural disasters is increasing, all of us know. The number of cyclones you get every year these days is increased. The global warming is resulting into the rising of the sea level, so the flooding is taking place. Chennai is no exception to that. So advanced modeling and analysis techniques are needed as far as to prediction of resilience to disasters are concerned. Advanced materials, as we discussed, continually they have to adapt to the requirements of high performance. There could be advanced steels, there could be composites, there could be biocomposites or whatever they are, but we have to look for the ideal material for the kind of problems which are facing. Technological advancements are also taking place today. It is not that we are static. Like, for example, I mentioned to you the complete journey, what has happened from 2000 on all BC and what we are today in terms of computational methods, in terms of digital modeling, digital twins, all this. And on top of that, because we are in the digital environment totally, the cyber security becomes most important. So while you may not be worried about this as a structural engineer, but as an overall project, if you make a smart city, if you make a smart building, if you make a smart structure, if you are not taken into account cyber security, I think it will be one of the non-performing asset. So it is important. And of course, you have always a requirement to handle the budget and cost constraints. It's always when you make a DPR, you ask 5,000 crores and government will give you 4,000 crores. And you have to now do that job in that 4,000 crore with the similar specification and same efficiency. So you know how the budgets are important for this. Regulatory compliance, as I mentioned to you, is a perpetual challenge because regulations also keep changing. And today, environmental clearances, the kind of forest clearances and all, they become a major issue for any infrastructure. Collaboration is very important here, very close collaboration, interdisciplinary, because you need a good material scientist, you need a structural engineer, you need a construction people, you need people who are good in digital technologies. For structural health monitoring, you need people who are good in communication, good in sensors. So you need a fairly large amount of interdisciplinary collaboration today. And globalization, navigating different standards. You are not doing just for yourself. Tomorrow you are going to build an structure in Bangladesh or Nepal for that matter. So you need to navigate the standards of different countries, their cultural norms, their different time zones and so on. So to conclude, I will say the way forward for you is the field of structural engineering is constantly evolving with new technologies and materials being developed all the time. This is leading to new and innovative ways to design and build structures that are more efficient, safe, and sustainable. The use of new materials, computer-aided design, building information modeling, advanced technologies, and the focus on sustainability are just a few trends that are shaping future of the structural engineering. As these trends continue to develop, structural engineers will need to adapt their skills and knowledge to meet the challenges of the 21st century. The other factors that are likely to have a significant impact on the future of structural engineering are increasing urbanization and the need for more resilient and sustainable structures. Looking ahead, it is imperative for structural engineers to stay abreast of these trends, ensuring they stay competitive in the dynamic and ever-changing engineering challenge. Thank you very much and wish you all the best for your Diamond Jubilee, which is a good start today, and I'm happy that I'm being part of that. And tomorrow, good activities throughout the year, celebrate the 49 or 50 of your progress. Thank you. Namaskar.
Thank you very much, sir. That was a very comprehensive lecture covering all the areas of structural engineering. On behalf of Director, we are proud to say that we work almost in most of the areas that was covered by you. Thank you so much for that comprehensive lecture, sir. As we step into our Diamond Jubilee year, our center is gearing up to celebrate with renewed vigor, focusing on promoting, nurturing, and commercializing innovative, reliable, and competitive technologies through various scientific initiatives. To give us a glimpse of these exciting endeavors and to kickstart them, I invite Sri R.D. Satish Kumar, sir.
அனைவருக்கும் வணக்கம். As already mentioned by Director, the Diamond Jubilee Celebration Committee opined that a unique logo to be designed and used throughout the year. We have invited our staff members to participate in the logo design competition. In response to the request, we have received 20 designs from 5 staff members. The committee chose the design submitted by Sri J. Ashish Jeevabalan, Project Assistant, SHRDD, under the guidance of Sri R.D. Satish Kumar. It is my pleasant duty to request the Chief Guest to release the Diamond Jubilee logo. Thank you very much, sir. I thank Srimati Sonia for preparation of the launch presentation. While CSIR-SERC celebrates its Diamond Jubilee year, the Journal of Structural Engineering, started by the founder director Professor G.S. Ramasamy, enters its Golden Jubilee by 50 years of successful publication. On this occasion, the chief guest to launch online journal article submission portal, a platform designed to streamline and enhance the process of submitting scholarly work for publication. Thank you very much, sir. As a publisher of the journal, I take the opportunity to thank all the editors of the past and present for their dedication in bringing out 50 volumes comprising 237 issues and 1,850 papers so far meticulously. I thank Srimati Chitra Sakaran, Srimati Anna Selvi, and Sri Ananda Krishnan for designing and development of this state-of-the-art platform. We are confident that this platform will empower researchers to share their work more effectively and contribute to the advancing knowledge in the field. I thank Dr. Vijayalakshmi and Mr. Surya for the preparation of the launch presentation. Now, I request the chief guest to release the compendium of projects by research. Thank you very much, sir. To commemorate the glorious 60 years of service to the nation, the CSIR-SERC Diamond Jubilee Conference on Monitoring, Assessment and Predictive Maintenance of Critical Infrastructure, IMAP, is being organized on 22 to 24 January 2025. Now, I request Dr. S. Gomathi Nayagam to release the Diamond Jubilee Conference flyer. Thank you very much, sir. On this wonderful occasion, a memorandum of understanding has been signed between CSIR-SERC and Ms. Pedwak Technologies Private Limited, Hyderabad, on developing advanced protective structures, components for ballistic, bulletproof, and baffled range products for advanced protection of personnel and property in India. To exchange the MOU documents, I request Sri B.N. Biddi Raju, Managing Director, Pedwak Technologies Private Limited, to come on the dais. I also request Dr. K. Satish Kumar, Head BKMD, to come on the dais. Thank you all.
Thank you, sir, and thank you to the chief guest also. On behalf of our center, we would like to express our heartfelt gratitude to our chief guest and guest of honor for their presence on this memorable occasion. And I now request our director to present a memento to both of the chief guests. I would like to invite Shri Loknath, officer, to deliver the vote of thanks.
Good afternoon, everyone. It is my duty to offer. We are thank to Dr. CSIR-SERC, Honorable Member, Niti Aayog, Government of India, for accepting to be the chief guest of this function and delivering Professor G.S. Ramasamy Memorial lecture in spite of his busy schedule. Sir, your thought-provoking lecture is quite helpful and eye-opener for the society. We thank to Dr. S. Gomathi Nayagam, former Director General, National Institute of Wind Energy (NIW), for accepting to be guest of honor for delivering first lecture of CSIR-SERC Diamond Jubilee lecture series. Sir, your lecture is quite inspiring for SERC. We thank to our director, CSIR-SERC, and coordinating director, CSR Madras Complex, who besides here busy schedule agreed to preside this 60th CSIR-SERC Foundation Day and inauguration of Diamond Jubilee celebrations. We are thankful to the chairman, Foundation Day Committee, Dr. J. Pravakar, Chief Scientist, CSIR-SERC, and all the members of the committee. We are thankful to BKMD, ICT, Advisor Management, Administration, Finance, Stores and Purchase, support services like electrical, AC, horticulture, housekeeping of CSIR-SERC. We are also thankful to all staff members of CSIR-SERC, CMC unity in charges, research fellows, project manpower, contractual manpower, directly or indirectly associated with this function for its grand success. We are also thankful to Srimati C. Bharati Priya, Principal Scientist, for anchoring the event. We also thank the press and media for being present here. Thank you all.